When we say electrical appliances, there is a wide range for that. But once we put a condition that it's a heating appliances, the list is a small one like geyser, heater, and based on heating effect, there are two more. One is fuse wire. Bulb is based on heating effect, but this is not the heating appliances because its function is not to provide you heat. Basically, bulb is used for providing light. See, when we say that there is a 60-watt bulb, the power consumed by the bulb would be 60 watt. It doesn't mean that it's going to give you the light also in equal amount. Actually, the percentage of energy produced by the bulb that is converted into light is very small one. That depends on the utility and the range of the electromagnetic wave produced by the bulb. So, don't try to conclude that the bulb is providing you 60 watt. It is consuming. When we say the bulb is of 60 watt, it simply means that the power consumed by the bulb is 60 watt. It may be giving you 10 watt, 8 watt, 7 watt like that in the form of light. You see, if you want to calculate the resistance of the bulb, power formula V square upon R. So, for calculating the resistance, you could proceed this way, and just by putting the value of voltage and power, we can calculate the resistance. For example, we have considered one particular value. Voltage already is always 220, and if you put the value of watt, you see it's here 60 watt. By putting all the values, you will finally get the value of resistance of the bulb that's having 60 watt power. That's equal to 1806 ohm. You see, power is inversely proportional to resistance, and resistance, is rho L upon A. Resistance is inversely proportional to area. 1 upon R would be directly proportional to area. So, you just omit this, skip this middle result. Power becomes directly proportional to cross-sectional area. We are talking about a bulb, the conventional source of light for us in domestic affairs mostly. Power is depending on the cross-sectional area, that means the thickness of the wire or the filament that is used in the bulb. You could say directly that for increasing the power of a bulb, we have to increase the thickness of the filament. This bifurcation has been shown here. For low power, you need high resistance, or vice versa. For greater power, you need low resistance, and for greater power, you need thick filament. Here, the filament should be, for low power, filament should be thin. Low power should be having greater resistance as shown over here. 25 watt bulb, it's having greater resistance. You see, a small resistance bulb means greater power. In parallel combination, greater power bulb will always glow more. That's the reason when you are having two bulbs in your room, one is 100 watt, other is 60 watt. When you switch on, 100 watt will provide you more amount of energy. Now, let's compare the functioning of heater and fuse wires separately. First come to heater. Suppose there are two heaters, you have to remember already that they will be connected in parallel. But the question for mathematical examples, we have both series and parallel possibilities. If you combine the heaters in parallel, because the resistance is going to decrease, obviously the power will increase. If you combine the heaters in series combination, their power is going to decrease. Suppose there are two heaters and they take time T1 and T2 in producing the equal amount of heat separately. Now, the mathematical question arises, if both the heaters are used together, what amount of time will be taken by them together for producing the same amount of heat? So you could say in series, since the resistance will increase, the time taken would be less. Why? Because time taken would be more, because the resistance increases in series combination. Once the resistance increases, power decreases. Power has decreased means less amount of heat will be produced and greater time will be needed. So in series combination, time taken by them will be T1 plus T2. In parallel, so going to be T1 T2 upon, as written over here, T1 T2 upon T1 plus T2. Fuse wire. Fuse wire is a, you might say, defensive device. It's not aggressive in nature. It only protects the domestic appliances for getting damaged. It is always connected in series. It is made of alloy of lead and tin. It has very small melting point. And the basic idea is that soon as the current withdrawn from the main source increases a particular limit, because of the excessive heat produced in the fuse wire, it will melt. It will melt and the whole circuit is broken. The domestic costly appliances that are in your houses like fridge and all that, that will be protected from undue damage. This is the basic functioning of fuse wire. One point is to be remembered that length of fuse wire is never material. It's only the cross section that matters for the fuse wire. You also remember that in parallel combination, bulb of greater power will glow more, whereas in series combination, bulb of greater power will glow less. In series combination, mostly decorative bulbs are connected like fairy light.